So we're going to work on solving algebraic expressions, they're called. So for the very first one, they've given us three models here. And they want us to create our expression from this. The first thing we're going to do is figure out what this is increasing by. Okay? So we know it starts at how many blocks in the first one? Three. And then the next block has? Four. And then the next block has? Five. Okay. So we're increasing each time by how much?
1.
That's right. We go up by 1. So when we go to make an expression, okay, we have something is equal to, we have our variable, which you guys usually call n, okay? And the number in front of n is how much we increase by. So I'll do it in blue. Okay, so I'm going to call it the increasing number. That's what this value is here, this unknown, okay? And then we usually add what's called a constant term, is what we start with. Okay? That's what most of these are going to be made up of when we do this. The problem is this is figure 1. What we want to do to make this easy in order to figure out what we actually start with, we want to go to figure 0. We want to go back 1. Okay, so I'm going to move this down a bit. We want to actually figure out at figure 0, according to this pattern, at figure 0, how many blocks would we have? Well, if it's always going up 1,
I'll go down 1.
That's right, we would go down 1, or it would be going up 1 from here. So how many blocks would we have to start?
2.
That's right, we would only have 1, 2, and I'm just using this to drag blocks out. I'm going to move it away now. Okay, let's get rid of that, and then I'm going to delete it. Okay, so we would actually have 2 to start. So that's actually telling us at figure 0, that's what our starting point is. So we always go back 1 to figure out how much we start with. Okay, so how many do we start with? The number
2.
2. Okay, and then this arrow saying increasing number, this increasing number is how much we're going up by. Well, how much does it go up by every time?
1.
1. So this number here is the number 1. So our expression is actually 1 n plus 2. And that's the expression for this one right here. Okay, so now let's say in this question, or they ask us for, oh, I don't know, they want us to find out, what was your question here? It was when w was equal to something, right? Let's say we want to figure out when there's going to be 50 blocks, okay, right? So when will there be 50 blocks? Okay, so remember, this n stands for what figure we're on, okay? That's what the n stands for, technically. So this n is what a figure number we are. Figure 1, figure 2, figure 3, okay? And just to prove it, let's say we're at figure 2. How many blocks are in figure 2?
4.
4. So let's take this expression and plug 4 in for n, okay? So we're going to say is equal to 1 times figure 2. All right, we replace the n with 2. Does that make sense, what we just did there?
Yeah.
For figure 2 plus 2. Well, what's 2 times 1? That's what that means. 2 times.
Don't you replace it with 4?
No, because 4 is the total. We're checking to see if there's 4.
Oh.
This is figure 2, though. So n stands for what figure number we are. So I replace the n with figure 2.
Oh.
2 times 1 is?
2.
And then 2 plus 2 is? Is that right? Are there 4 blocks in figure 2?
Yes.
There's 4 blocks. So it tells us from our expression.
Guess.
So we want to find out
When will there be 50?
when will there be 50 blocks. So this, notice I haven't written anything on this side. What we actually do here is we write that number on this side of the expression. So our expression was 1n plus 2, and we want to know when there's 50. Okay. So we want to know when there's 50 blocks altogether. So here what we have to do is we have to isolate n.
Okay.
Okay? So have you heard of bedmass?
Yes.
Usually when we isolate, bedmass usually goes from left to right. We do brackets, exponents, division, multiplication, addition, subtraction. When we're isolating, we usually do what's kind of known, it's not exact, but we usually refer to it as reverse bedmass.
Okay.
So normally what would we deal with first? We normally in this question we would deal with the multiplication, right? And that's what we did here. We dealt with 1 times 2 first. Well, In this case, we deal with the addition first. And when we're isolating, we're moving the addition part to the other side. Okay? When I move it to the other side, do you know what it becomes? Or what that process is? What do you guys do? Balancing an equation? You've never done anything like that? Okay. So what we do here is we have to balance an equation. So this equal sign, think of it like the middle. And whatever I do to the right side, I have to do to the left side. So the goal is to get n all by itself. So I want to eliminate this positive 2. Okay? What would make positive 2 0? What number?
2.
Subtract 2. So my next line, I need to subtract 2. So on my right side, I'm going to have 1n plus 2 minus 2. But whatever I do to the right side, I have to do the exact same to the left side. So I have 50 minus 2. So notice I did it to both sides. Okay? This is important. And then we simplify. What is 50 minus 2?
48.
So this side becomes 48 is equal to 1. And what is 2 minus 2?
0.
Plus 0. Okay. What's 1n plus 0?
1.
1n, right? There's nothing to it. 1n is equal to 48. Okay. I have to get n by itself. This technically says 1 times n.
Yeah.
What's the opposite operation of multiplication?
Division.
Division. So I need to now divide both sides by the number 1. Okay? And what will happen is they usually call it canceling out, but it creates a 1. Well, when I divide both of these by 1, it just makes the value of 1. Okay? So just keep this set in mind. So now I just have n here. They've kind of canceled out. And what's 48 divided by 1?
48.
It's 48. So, what figure number would we be at when we have 50 blocks?
40.
Figure 48.
Oh.
Figure 48 will be at 50 blocks.
Okay.
Okay? Did that make sense on how to
Yeah.
create and isolate?
Mhm.